Welcome to AGU Fall Meeting 2020. We are excited to have more than 20,000 attendees from over 110 countries around the world join us for our first 100% virtual online meeting. Here are some of the leaders who are shaping the future of science.
Hello, I'm Beth Stoltzenberg, President of the Atmospheric and Space Electricity Section. We study electrical phenomena, including lightning and all its effects, cloud electrification, and non-thunderstorm electricity on Earth and other planets.
We are shaping the future of science by developing new techniques to map lightning with meter scale and nanosecond precision.
Developing new sensors and techniques to understand the electrical atmosphere.
My team is shaping the future of science by investigating the extreme bursts of high-energy radiation produced by lightning strikes all over the world.
We use custom-made atmosphere sensing instruments combined with computer simulations.
The X and gamma ray instrument is now flying on the International Space Station.
Together, we can do it! Thunder, 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 feel the thunder, lightning and the thunder, feel the thunder.
Hi, my name is Benjamin Nalt, and I'm a postdoctoral researcher at Paradigm Research Inc., head of the Early Career Committee for Atmospheric Science Section, and member of the Executive Committee for Atmospheric Science Section. On behalf of the Atmospheric Science Section, I welcome you to the AGU Fall Meeting 2020, the first all-virtual AGU Fall Meeting. While this is a time of celebration for the research you have completed in the last year, where the Atmospheric Science Section has nearly 3,000 presentations from all over the world, including biospheric interaction, air quality during COVID, and cloud and boundary layer dynamics, 2020 has also shown to be a year of reflection. As a section, we have started assessing and evaluating how we can ensure underrepresented communities are better represented in presentations, including invited presentations, and leadership positions, and overall in the community, as this can improve the science and discussion throughout the community. So while learning about the research, use this time to reflect what you can do and enjoy your time during AGU Fall Meeting 2020.
Hello, this is John Frank of the U.S. Forest Service, and I represent the Biogeosciences section of AGU. We work with a large network of scientists called Ameriflux, which is part of a global effort to understand biosphere-atmosphere dynamics. Terrestrial ecosystems are crucial in helping to mitigate climate change by absorbing some of the anthropogenic CO2 emissions. Our data show how the ecosystems breathe in and out CO2 and are used to validate Earth system models. Thousands of researchers contribute to this global effort, and we share our data freely. Ultimately, our collaborative research is helping improve understanding of mechanisms regulating greenhouse gas concentrations in the atmosphere. Again, hello from Ameriflux and AGU Biogeosciences.
We're the ISF Academy in Hong Kong, and we're really pleased to be part of the AGU Bright Stars session online. We'd love to be in San Francisco this year, not to be, but we look forward to seeing everybody in New Orleans next year. Bye for now.
I'm Zoe Corville, on site at McMurdo Station, Antarctica, from the Cryospheric Section of AGU. Cryospheric Science studies the frozen parts of our planet, from pole to pole and beyond, as we discover more icy regions of our solar system. We are an interdisciplinary section with 1,300 primary members and over 3,000 secondary members. The Cryospheric community is committed to increasing diversity among our members and tackling the challenges we all face, understanding the role of the cryosphere in the Earth's changing climate, and exploring the unknown parts of our solar system.
We are excited to introduce the future of the Earth and Planetary Surface Processes section, a multidisciplinary field focused on how landscapes evolve. I am Marissa Palusas, an assistant professor at Dartmouth College.
And I'm Claire Masteller, an assistant professor at Washington University in St. Louis. And we want to showcase that what makes our section thrive is our commitment to embracing diversity in all forms.
Diversity of scale.
Diversity of approach.
Diversity of perspective.
And most of all, the diversity of our EPSP scientists.
Hello everyone, my name is Dr. Sarah Remdeen and I'm Secretary for the Earth and Space Science Informatics section. Like many people in informatics, I have a cross-disciplinary background with an undergraduate degree in geology and a PhD in information and library science. If you've ever heard of the term FAIR or maybe FAIR data, findable, accessible, interoperable, and reusable, these are concepts that EC endeavors to support. We also engage the broader AGU membership on concepts such as data management and analysis, large-scale computational and experimentation and modeling, hardware and software infrastructure needs, and other concepts that all help support the broad range of Earth and space science research. Topics emerging from EC at the fall meeting include machine learning, semantics, cloud computing, and leading practices around data management, data repositories, and data rescue and conservation. If you want to learn more about becoming part of the EC community, join us on our town hall Tuesday, December 15th, number 87. And on behalf of EC, I'm proud to welcome you to the fall meeting.
The AGU Education Section seeks to catalyze and shape Earth and space science education activities to develop a diverse Earth and space science talent pool, improve global scientific literacy, and increase access to scholarship and collaboration in Earth and space science education research and practice.
Hi, I'm Shahab Academy Fact.
And I'm Alicia Peterson. We are the student and early career representatives for the AGU Education Section.
Hey everyone, my name is Alex Phillips and I am a graduate student at the California Institute of Technology, and I'm also the founder of the social media project called Women Doing Science of the AGU Education Section, and I hope to see you all at AGU this year.
Hi, I'm Tanya Furman, incoming president of the Education Section. Join us at AGU.
We all shape the future of AGU education together.
Find out more on our website.
Follow us on Twitter.
And we'll see you at the AGU.
Hi, I'm Rebecca Rear, a co-chair of the policy committee of the GeoHealth section. The discipline of GeoHealth is advancing our understanding of the complex interactions between the environment, including earth, water, soils, and air, and the health, well-being, and continued progress of human populations. Members of this community represent diverse backgrounds in geophysical, biological, and public health science, and share a passion for research at the nexus of earth and health sciences. Me? I work at the intersection of climate change and human health, helping folks understand the ways that our reliance on fossil fuels is harming the world we're living in and directly hurting us. We have longer and more intense storms, raging wildfires, more bugs in more places that carry diseases, and those who contribute least to the issues, lower income and Black and brown communities, are hit first and worst. And all of this takes a toll on our mental health too. But we have massive potential for equitable climate action. As the GeoHealth section, we are looking to continue research at these intersections and lead on solutions. We're hoping you'll join us. Have a great fall meeting.
Hi, I'm Sarah
Slotsnik. The Oxford Magnetism Group.
Starts University.
University of Liverpool.
The University of Colorado Boulder and NOAA MCEI.
University of Florida.
Early Earth and planetary magnetism.
Early mixing in the solar system.
Understanding the rock record through iron mineralogy.
Developing geomagnetic field models and doing basic and applied research in geomagnetism.
Records of the geomagnetic field and archaeological timescales.
Quark convection and the associated dynamo process.
Collecting samples from all over the world.
Oh.
Hi everyone. I'm Lynn.
And I'm Christina.
Global environmental change focuses on large-scale changes across the Earth over decades to centuries.
We make up a vibrant community of scholars with more than 11,000 members from 93 countries. We have an expansive diversity of research fields, and we'll highlight a few researchers now.
My research uses machine learning and statistical modeling to improve the quality of long-term satellite data records for climate studies.
I study phenology, when cherry trees bloom in the spring, and when trees shed their leaves in the fall.
I'm Ethan Young, assistant professor at Lehigh University, Pennsylvania.
Hi, I'm Katerina Matos, an aspiring PhD student for the fall of 2021.
Hi, I'm Leila Saberi, the AGU Hydrology Section student representative.
The Hydrology Section has nearly 7,000 AGU members who are hydrologists, engineers, policymakers, and educators. As water travels through our planet, it touches every aspect of our lives and integrates all disciplines of Earth and space science.
Our members are working on understanding the fate of water resources under a changing climate. We recognize water as a basic human right, and we commit to promoting solution-driven science to support those most affected by the devastating effects of climate change. It is our responsibility to prevent the next Flint, Michigan.
Science advancement is fast-tracked when we have diverse range of backgrounds and ideas represented. And we are proud to have the Student Subcommittee leading the way to ensure that this section fosters an environment of justice, equity, diversity, and inclusivity for all.
Hi, we are the 2020 graduate honorees of the Mineral and Rock Physics section. My name is Martin Lussier from Lawrence Berkeley National Laboratory, US.
And I'm Leif Togel from ETH Zurich in Switzerland.
I am Francesca Miozzi from University of Milano in Italy. The Mineral and Rock Physics section focuses on the study of the properties of material from the Earth's interior and planetary interiors. I am doing so by making high-pressure and high-temperature experiments to constrain the properties of planetary building blocks.
I am computing numerical simulations of multiphysics processes in the rock at the grain scale, verified by experiments at the laboratory scale.
And I'm using rock deformation experiments and the rock record to constrain the rheologic properties of planetary materials. And together, we are shaping the future of mineral and rock physics.
Hello, I'm Jessica Watkins, NASA astronaut and planetary geologist. It is an honor to be a part of this roll call for this year's AGU fall meeting. In graduate school, I studied Mars surface processes, focusing on large landslides on Mars and on Earth. As a postdoc, I worked on the Mars Science Laboratory Curiosity rover, helping plan its daily activities and investigating the geologic history of Gale Crater. Studying Earth helps us to understand the fundamental geologic principles that we can then apply to the Moon, Mars, and planets beyond. And as we explore new worlds, we in turn discover more about ourselves and our home planet. I'm excited to be a part of NASA during its Artemis program, which will send humans to the Moon and expand our understanding of the Moon, the Earth, and the solar system we live in. But whether we're at the lunar South Pole or the Antarctic dry valleys, the Earth and space science community will help shape the future of science and the future of exploration, wherever it takes us. I wish you all a great AGU, and I look forward to seeing you in person soon.
The
Natural Hazards section works to understand the geophysical underpinnings of hazards such as fire, floods, volcanoes, earthquakes, and landslides. In addition to physical science, our section conducts interdisciplinary research aimed at reducing vulnerability to both current and future hazards, and implementing effective strategies for hazard mitigation worldwide, with a particular focus on the most risk-prone areas and people.
This year, there's been a global and overdue call to action to address systemic inequities, including in the preparation for, response to, and recovery from disasters.
Our recently formed Hazards Equity Working Group is shaping the future of science by creating a forum to discuss these issues within our community of practice, providing resources for scientists to include equity and demographic elements in their work, and advocating for increased support for equitable scientific initiatives within AGU and externally.
Hi, I'm Anja Klotsche, recipient of the 2020 Near Surface Geophysics Early Career Award. In the Near Surface Geophysical section, we use geophysical tools to map and monitor shallow subsurface properties with applications that connect many of our AGU sections. And here's what some of our members of the Near Surface community are doing.
I'm Christina Keating, and I study nuclear magnetic resonance.
Hi, I'm Dave O'Leary from Ireland, and I'm using airborne radiometric data to map intrapeat variability.
I'm Andrew Binley, and I'm interested in hydrogeophysics.
Burke Minsley, and I use airborne geophysics to map Earth's subsurface.
I'm Kamini Singh, and I use electrical methods to study hydrogeologic problems.
Paulo Freire. I apply electrical and electromagnetic geophysics for the design of electrical grounding systems.
This is Lee Slater and Xavier Comas.
20 years of peatland geophysics.
In Caribou, Maine.
Mindy Kimball, and I use geophysics to do geoarchaeology.
We are Ocean Science, and we are charged to explore 3/4 of the planet. We represent a diverse global research community requiring interdisciplinary methods to explore the ocean's physical and biological relationship, all while training the next generation of ocean scientists. We shape the ocean future. For instance, we work together from ship to shore to limit gaps in long-term observations of the Arctic Ocean. Our tools include innovative technologies such as satellite remote sensors, autonomous underwater instrumentation, and high-resolution sonars. We explore because the ocean's role in climate science is emerging.
Hola, me llamo Benjamín.
Mi nombre es Raquel.
Nos sentimos orgullosos de representar la sección de paleoclimatología
y paleoceanografía en el AGU Roll Call 2020.
Nuestra visión para el futuro de las geociencias es una comunidad diversa,
inclusiva,
equitativa
y justa. Y con estos principios
podemos hacer ciencia que impacte a nuestra comunidad
y todo el mundo. Nos vemos en AGU.
Hi, I'm Ashley Schoenfeld.
And I'm Sam Birch.
And we're the student and early career representatives for AGU's Planetary Science section.
Our section encompasses all that's related to the investigation and exploration of our solar system and its diverse inhabitants.
Using a variety of investigative techniques, members of our section are interested in understanding the properties and behaviors of each planetary body, from the core and through the magnetosphere. This includes, for example,
volcanoes on Venus,
ice on Ceres,
geophysical fluid dynamics,
volcanoes on Io,
outer planet magnetic fields,
geologic processes on icy satellites,
ultra-low altitude spacecraft dynamics,
laboratory experiments on Titan,
alien organic minerals on Titan,
cometary activity,
ice phases on different planetary surfaces,
ice volcanoes on Pluto.
Planetary science is as much about understanding our celestial neighbors as it is about understanding this pale blue dot we call home.
Don't believe us? Take it from our best friend, Bill.
Greetings, everyone. Bill Nye here. There's never been a more exciting time in geophysics. The more we learn about other worlds, the more we will know about our own. So let's get out there and explore the planets.
The Science and Society section aims to create a welcoming community for artists, communicators, policymakers, social scientists, community members, and other decision makers, so that scientific discoveries and solutions can benefit humanity.
We build collaborations with other AGU sections that enable science to better address societal needs.
We provide mentoring opportunities for scientists interested in policymaking, communicating science, and effectively working with communities.
Scientists have a critical role to play in advising all levels of government and contributing to public policy.
We work with communities, including historically marginalized ones, to advance their priorities through collaborative projects with researchers.
Communicating science can have a variety of goals, from creating awe to informing decisions.
Both artistic and scientific endeavors are used to explore and understand the world around us.
Social sciences can help us understand how people and institutions think, feel, and behave.
It is important to our future to connect science and society. Join us.
Friends and colleagues attending the 2020 AGU Virtual Conference, it is my pleasure to introduce to you the Seismology section. We are the University of Rochester Seismology Group, UR Seismo. I am Toloba Olugoji, and with me are Evan,
and Steve.
Yeah, our planet Earth is our single and shared home. And with seismology, we study its interior at various scales. For example, here at the University of Rochester Seismology, we use ground vibrations and smart machines for Earth imaging on land, in the sea, and at remote locations on the African continent. We make the invisible Earth visible. Thank you for joining us, and we hope you enjoy the rest of the conference.
We're the Space Physics and Aeronomy Student Committee. Welcome to AGU Fall 2020. The SPA section is united by its interest in the sun, heliosphere, and magnetosphere. Our projects range from shock physics to dust plasma, from ionic electric fields to Alfvén waves.
As an early career scientist myself, I remember what it was like trying to figure out where I would find that open door. Thankfully, the SPA Student Committee is here to help those who may be looking for their next opportunity. Whether you're an undergraduate, graduate, or early career scientist, we're here to help you find resources and open doors so that we can get you from point A to point B and beyond the moon.
With today's advances in computing and algorithms, global modeling will become more and more feasible. But to get that done, we'd need different parts of physics to come together. And space physics and aeronomy bring together those elements that would make us create more refined and better global models of atmosphere.
Space physics and aeronomy has countless applications, from the darkest parts of the solar system to our home planet. Thank you, and we'll see you at AGU.
Greetings from the Study of Earth's Deep Interior section, or SETI, and from Moscone Center in San Francisco, California, where we would be gathering together under normal circumstances. We are mineral physicists, geodynamicists, geochemists, and seismologists studying the interior of Earth to learn about its formation, evolution, and structure. We are shaping the future of science by understanding how mechanisms hundreds to thousands of kilometers below our feet affect issues impacting our lives.
And SETI researchers look beyond the Earth, looking to understand the interiors of worlds across the solar system.
By now you've seen some snapshots of really amazing early career scientists of SETI. I personally experiment on iron alloys at extreme pressure and temperature conditions to simulate the Earth's core. The nano and microscale properties of the core affect its dynamics, and hence the geodynamo-produced magnetic field, which protects life on Earth from harmful ionizing radiation.
And I study the interiors of small worlds across the solar system, using gravity data and whatever else we can get.
Hi, I'm Rachel Marsden from Columbia University, and I'm a member of the Titanophysics Section at AGU. The Titanophysics Section is really great in the sense that it brings together a lot of disciplines, including geology, geochemistry, and geophysics, in order to understand how the Earth deforms through time. In my research, I tackle these questions in the southeastern United States, which is a passive margin setting today, but had a lot of mountain building and magmatic activity that provides the opportunity to study how plate tectonics works.
For years, activists in Belmont County, Ohio have been worried about their air, their health, and their community.
I can't believe that the Ohio River Valley would be condemned to being turned into a petrochemical corridor like this.
Now, scientists and activists are fighting for clean air together. Hi, I'm Garima Rahedra. I'm an atmospheric scientist at Columbia University, and today I'm proud to introduce the concerned Ohio River residents and the Thriving Earth Exchange. Building a coalition across the region, we are monitoring, modeling, and mapping our air pollution, and demystifying all of it for the citizens of the valley. Together, we are shaping the future where science and society come together to solve our most pressing problems for our communities which are fighting the toughest battles. To learn more, look for Thriving Earth Exchange this year at AGU's fall meeting.
Hello, everyone. We, the past and present members of the EPIC Lab at Arizona State University, are glad to represent volcanology, geochemistry, and petrology. Like VGP members the world over, we face many obstacles in the world today. But we are so thankful for you and the opportunity to come together and build community at the Fall 2020 meeting, discovering the inner workings of our planet, from its deepest interior to its newest crust. We are shaping the future of science.
Through laboratory experiments,
field sciences,
high precision analyses,
integrative models,
and by valuing the contributions
of all voices
and
ideas.
To all of you who participated either in the introduction or are joining us for the fall meeting, thank you for being a part of our community. Now let's start AGU Fall Meeting 2020.